See that very well. I'll go over it in black. So we have I equals the square root of -1. Okay. So now if I take that out, new board, if I take that out, then I can write this as not just x equals square root of -8, but it would be x equals it would be I square root of 8. So that takes out the negative, okay? Because square root of -1 is I. So if I take out that negative, if I take out that square root of -1, now I'm just looking at square root of 8. Now square root of 8, I can simplify because 8 is made out of 4 and 2. And I can take the square root of 4, but I can't take the square root of 2. So if I take the square root of 2, so what this is I'm going to simplify this. That I is going to stay there because I can't just get rid of it, right? So when I take the square root of 4, that is a 2 that comes out. And then that I, and then there's a 2 that gets left behind. Okay? Now, since I'm solving this, this would also be the plus or minus option. Okay, so because I'm solving it when I take the square root, these are my plus and minuses. Okay. Oh yeah, imaginary numbers are weird. Imaginary numbers are really weird. Yeah, so see, this is quadratic functions. Okay. This is quadratic functions. Yeah, there's no real solutions for this one. And if you were to graph this, what you would see is when you graph these, what they look like is, because they're going to still be a parabola, right? So, but they're going to be something like this. okay, where they don't actually touch the x-axis, which is where you find those roots and those solutions. So the fact that they don't actually touch the x-axis, but again, this is the solution because they're imaginary because you can't draw them on this coordinate plane. Okay. What purpose does I serve? Why did mathematicians make I and not just say it's unsolvable? Because they just wanted to work with more numbers. I don't know. It was literally just because it was like these, you could still solve it if you just took out that negative. So they just wanted to work with it more, right? So I does come in handy when you're working with these more advanced solutions. But I mean, it's kind of a pain in the butt. But that's okay, because it's still kind of fun to work with. So this is typically done in like an Algebra 2 class. Definitely something that you'll see in pre-calc and Algebra 2 when you have this. Okay. All right, let me see. Oh, here's my mouse. To keep track of all my different mice. Nathan, what do you want to do with polynomials? Let's see. Oh, Shadow Llama. I do algebra all day and I love it. Okay. Let's see. So Dylan, currently in Algebra 2, I'm nervous but excited to learn about imaginary numbers. They're really fun to work with. I do like those. Krista, with y equals mx plus b. I can totally help you with y equals mx plus b. Can you give me a little more information about that? Are you going from a graph? Are you going from 2 points? What are you going with? Cody, how come you use plus negative? Do you mean this plus minus? It's because when you take the square root of something, when I'm doing a solution, because like the square root of 9 could be positive 3, but it could also be negative 3. So that's why you say it's the positive version or the negative version of this. All right, Chris and Nathan are both asking for polynomials. Okay, so adding, all right, Chris, so you learned this today in Algebra 2. Okay. Search about the Cardano's formula. Ooh, interesting. Okay, so quadratics using distributive property from the graph when the y-intercept isn't labeled. Okay. All right, so we've got, okay, so long division with polynomials. Okay, I gotta start my list, guys. Okay. All right, so we're gonna do slope intercept. That's the y equals mx plus b. We'll do some polynomials. Operations and division. Long division. Let me see. Sorry, guys, you're all filling up the. Oh, Steven over on YouTube is asking, what is the answer to the math problem? So this one, the answer would be positive or negative 2i root 2. Okay, let's see. Okay, quadratic. Yes, Emmy, I see quadratics using distributive property. Okay. Emmy, can you give me a specific question on that with quadratics using distributive property? All right, integrals. We don't really get into integrals here, but if you have a specific question about anything, like we usually stop kind of at like the very beginnings of pre-calc. We kind of go pre-algebra through a little bit of pre-calc. Yeah, but if you have a specific question about integrals, put it in the chat because we have a really good community here. Okay, so I've got polynomials. We can talk about domain and range. We can even talk about that. All right, domain and range. Who was asking for domain and range? Junior, Domain and range. Tell me a little bit about like what math level you're in and all of that, because that gives me a good idea about what domain and range you're looking at. Okay, so Xander. So I've got polynomials long division, Mark. I've got that on my list. Okay, triangle similarity. Scarlett, yeah, usually. It's usually based on your grades for this year. Okay, and then we can do triangle. Do like AAS, SSS, all that stuff. Okay, this is a good starting list. Okay, so slope-intercept form of an equation, and then we'll get into polynomials. So those of you who are waiting for polynomials, just sit tight for a minute, and we're gonna talk about it. But this is a good review for everybody. Okay, so slope-intercept form, when you don't have algebra x and y functions with two, oh, okay. That's a solution or a system of equations. Okay, so here we've got the coordinate plane, right? We've got the x-axis and we've got the y-axis. The x values are all the domain. The y values are all the range, okay? So when I have a line, when I have just like a straight linear equation, something like this, okay, and if it just kind of keeps going on and on and on, okay, my domain would be all real numbers because it's the x values, it's going to go through all of them. My range would be all real numbers because my y value is going to go through all of them. Okay, my y is going to pass on. It may be way down there, but it's going to eventually pass through all of the x and y values. Okay. All right, so we've got on this line, let's see, I just kind of drew this out. So let's see, I'm gonna do this point and this point, okay? So what we're gonna do is we're gonna write the linear equation for this graph from this, or for this line from this graph, okay? So this point here is 1, 4. We list the x first and the y second. So we go out to 1 and then we go up to 4. Every time we go graph plot a point, we go back to the origin. So here is -2 and 6. Okay, so there we go. So these are our 2 points. And again, we're going to write out the linear equation. We're going to write out the slope-intercept form of this equation. I'm just going to erase this so we have more room to work on here. Okay. So with slope-intercept form is y equals mx plus b. So this equation is relating the x values and the y values. Okay. The m is your slope, which is rise over run. So m is your slope. Okay. And the b value is your y-intercept. Right? Your b value is your y-intercept, which is where it intersects with the y-axis. This is your y-intercept. Okay. All right, so to find these, the first thing we need to do is find the slope. Slope is rise over run. So my slope, so you can do this by figuring out how much is the y changing and how much is the x changing, but rise over run is also where you're looking at, if I take this slant here, this diagonal here, okay, I can break it down. Think about like a ramp versus stairs. I'm really just looking at it like, what are the stairs, right? So I'm going down 2, and over 3. So my slope is -2 over 3. I could also do this by doing 4 minus 6, which is -2, and 1 minus -2, which is 3. Okay, so slope is the change in y over the change in x. So there's my slope. Okay. Here I have a choice. Some teachers will have you use point slope form because I have a point and I have my slope. Some teachers will just have you plug it into the slope intercept form and just boop, go on with that. Okay. Yeah, so this is usually Algebra 1, pre-algebra, some middle school math, they'll do this. They'll do this. So point slope form is where we go y minus y1 equals m times x minus x1. So the x1 and the y1 are the coordinates from your point. Okay, and you can pick either one. As long as you pick one and stick with it, I'm going to stick with 1, 4 because I don't want to deal with the negatives right now. Okay, and then I have my slope. So this x and this y, they're going to stay as x and y because I do need an x and a y in my equation, right? So so here I'm going to plug in, I'm going to choose 1, 4. So I have y minus 1 equals -2/3 times, nope, sorry, that should be y minus 4, not y minus 1. So it should be y minus 4. Okay. Sorry, I misspoke on that. So y minus 4 equals -2/3 times x minus 1. So the 1 came from there, the 4 came from here. Okay. All right, now to get it into slope intercept form, I need to get that y by itself. Okay, first thing I'm gonna do, I'm gonna distribute that -2/3. So I've got y minus 4 equals -2/3 x plus 2/3. And now again, the request was doing writing out an equation for a line that it doesn't really show you the y-intercept. Okay. So now I need to get y by itself. Well, I've just got to solve. Oh my God, one of these days this chair is going to tip over. That's going to be hilarious. Okay. So then we're going to add 4 to both sides. So that leaves y by itself, -2/3 x. 2/3 plus 4 is going to give me 14/3. Hold on. Positive 14/3. So plus 14 over 3. So that is my equation. This is the equation for that line up there. I took my 2 points. I found my slope, right? Slope is just rise over run, which is the change in y over the change in x. Okay, and then I put it into point slope form and went all the way through. Okay. Yep. So math dude, I prefer just plopping them into slope intercept form and just the b is whatever it is, right? But a lot of teachers are shifting to the point slope form. Okay. All right. How do I get 14/3? It's 2/3 plus 4. I had to add 4 to both sides. So 2/3 plus 4 is going to be 14/3 because 4 is 12 over 3. Okay. Math dude, I appreciate you too. Okay. Let's see. So Jackson, this is definitely right in the realm of 7th grade algebra for sure. Nathan, are you asking for like a system of equations? Okay. So we've got, let's see, we kind of talked about domain and range. Okay. Polynomials are up next. No, a bunch of people were begging for polynomials earlier. Okay. So polynomials. Okay, so polynomials are just equations or expressions with multiple terms. Okay. So poly means many, nomials means names or, terms. Hi, Mac. Okay. So polynomials are many terms. So when we are multiplying, adding, subtracting, all of that, we want to look for like terms. So this is going back to like way basic, like just starting out with simplifying expressions and things like that, where you would look at something like 2x squared plus 5x minus 9 plus 2x plus 4x squared, right? So you would look for the common terms, right? The like terms. So 2x squared and 4x squared, they both have the same variable to the same power, so I can add those together. So 6x squared. And then positive 5x and positive 2x, so I'm going to add those together, so that's plus 7x. And then negative 9 is just the only number that we have, so it's minus 9. So this would simplify down to 6x squared plus 7x minus 9. Okay. All right, so polynomials can get a lot more complicated. Okay. So tool fan. And you do approaches for middle school word problems. Oh, yeah, those are tough. I just kind of I go through and I talk to them about just kind of finding the math in there, right? But it just takes a lot of practice. Yeah. Okay. All right, so we can equal this to 0 for sure. All right, so if we equal this to 0, now I have no idea what this is going to be. I just made this up. But let's go ahead and see. So simplifying the expression is something you usually learn in like algebra 1 or pre-algebra, right? Maybe even like 6th or 7th grade math. But here we've got this 6x squared plus 7x minus 9. This is usually where you get into more advanced algebra 1, more algebra 2, really, you will be doing this a lot, okay? All right, so we've got 6x squared plus 7x minus 9. So what I'm going to do, there's lots of different ways to solve this, okay? I could try to factor this. I'm not going to try to complete the square because I don't want to do that. But I could also do the good old standby, which is the quadratic formula, okay? So we can do this. So bonjour, I'm going to do dividing cubic. I'm going to be doing, well, I think it would be 4x cubed plus x squared plus 5x plus 2 divided by x minus 2. I'm going to do that next, okay? I'm going to get to that in just a minute, but let me write this one down. 4x cubed plus x squared plus 5x plus 2 divided by x minus 2. Yeah, so bonjour, I'll get to that in just a minute. Okay, so here, I'm just going to go with the quadratic formula because I don't feel like factoring it. So we're going to go with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you to those of you who were singing along with me. Okay, I wasn't really singing, but in my head I was. Okay, so b is 7, a is 6, and c is negative 9. So now we just simplify, or we plug in, and then we're gonna solve. All right. So we are looking at. I'm gonna move this all down here. X equals negative 7 plus or minus square root of 7 squared minus 4 times negative 9 times 6 all over 2 times 6. Okay. Ugh. Let me get my trusty little NumWorks calculator out. You guys know I am a big fan of this calculator. So NumWorks calculators, you can click a link, do the stuff. If any of you are math teachers out there, you can get a free graphing calculator. All you have to do is go to their website and sign up. Honestly, truly, there's no strings attached. Those of you who want to try it out, the app, the emulator is free. You can get it on your phone. You can get it on your tablet. You can get it just online. You can try it out and see the really cool stuff that it does. Okay, that's my little spiel. All right, so I'm going to go with, let's see, 7 squared minus 4 times negative 9 times 6. All right, so I get 265. 7 squared minus 4. Okay. So I go x equals negative 7 plus or minus square root. Did I say 256 or 265? It's 265 over over 12. Okay, so root 265. It doesn't simplify down. So actually none of this really simplifies down. So that's my solution. That's it. That's my solution. So negative 7 plus or minus root 265 over 12. That's my solution right there. Okay, so just looking at this, because this is an irrational number, I could not have factored this. So doing the quadratic formula was the right choice. Okay, so polynomial division. Okay. So polynomial division, Bonjour asked for us to get into the polynomial division and specifically this question. So we've got 4x cubed plus x squared plus 5x plus 2 divided by x minus 2. Now this is something that comes up a lot when you start having to solve polynomial functions. Okay. Hello, we don't really get into calculus here, but if you have a specific question, you can put it into the chat and then we can get into it. Danny, yes, we do geometry. I'm gonna get into this. I can do a little bit of Pascal's triangle. SPS, can you do algebra 2? Yeah, I mean, this is algebra 2 that we're doing right now, so you gotta be a little bit more specific. So we primarily do like pre-algebra through algebra 2 or getting into, the, oh yeah, there's so many videos on YouTube. Okay, so let's get into this division, okay? Now, long division of polynomials follows the same basic pattern as like what you did for long division way back in the day. SPS, yeah, I do tutor algebra 2. If you are needing a tutor, you can click the link in my bio and check it out. Okay, so this number is gonna, or this polynomial is gonna go into the little house. Okay, and then we've got x minus 2 out here. All right, so long division, right? You see like, okay, how many times does this go into this? And you put it up there, you bring it down, you multiply, you subtract, all of that kind of stuff, right? There is an easier way to do this that's not long division. You could do synthetic division, but typically this is the way you're gonna learn it first. So that's why we're gonna go through it, okay? All right, so when I'm doing long division of polynomials, I'm just gonna pay attention to this first term. So in this case, it's just x, right? And I'm just gonna pay attention to this first term. So I say, okay, x times what is 4x cubed? I could also think about this as 4x cubed divided by x is what? So that's gonna be 4x squared. Because 4x squared times x gives me 4x cubed. Now I can't just ignore that minus 2, but it goes along for the ride. So then I do 4x squared times negative 2, and that's going to give me minus 8x squared. Okay. All right, so then I subtract, just like I did, you know, way back when. I'm going to have x squared minus 8x squared. So that's negative 7x squared. And then I bring down the plus 5x. And I do it again. And I'm just looking at this first term and this first term. So x times what gives me negative 7x squared? Minus 7x will give me that. So negative 7x times x gives me minus 7x squared. And then the minus 2 is just along for the ride. So I do negative 7x times negative 2, which is plus 14x. And now I subtract. Negative 7x squared plus 7x squared cancels out. Great. 5x. If you ever get into the point where you go, oh, those didn't cancel out, go back. You probably made just like a little error or something up here, okay? So 5x minus 14x gives me negative 9x. And then I bring down the 2. Okay, well, I'm going to need another board for this. We're going to need a bigger board. If anybody wants to send me some new whiteboards, that'd be great. Okay, so now again, I'm just going to pay attention to the first two terms. Okay, x, negative 9x. So this is going to give me, I'm going to go minus 9. So negative 9 times x gives me negative 9x. Negative 9 times negative 2 gives me plus 18. And then I subtract. The 9x's cancel out, and then I'm left with negative 16. That's my remainder. Okay. Now my remainder, I know this is something that I usually get into with my students, like, because when you had a remainder, then, you know, if you keep thinking about it with the decimal, you kind of do the remainder divided by that. That's where your decimal comes from. Okay. My first subtraction is wrong. I don't think so. Oh, you're right. I did x squared minus, oh, you're right. Oh no. Thank you. Okay, I did make a mistake. Oh my goodness. Okay, thank you to I can't even remember who pointed that out. You are absolutely right. Oh my gosh. Okay, so let's go back, but the process is still the same. Okay, so let's do a little, let's speed this up. Okay, so x squared minus negative 8x is going to actually give me 9x squared. I'm still going to bring down the 5x, boop, boop. And then I'm looking at x times what gives me 9x squared. That's going to give me plus 9x. So this is 9x squared minus 18x. Subtracting. These cancel out. 5 minus negative 18 is 23x. I bring down the plus 2. X, it's going to be plus 23. 23x minus 46 minus, so that's going to be 48. Okay. Yeah, this is definitely algebra 2. This is probably like 10th grade. Yeah. Okay, so 48 is my remainder. Okay, now 48 as my remainder goes over what I divided by up here, which is x minus 2. Okay, so my answer to this, my solution, is this whole part up here. So I have 4x squared plus 9x plus 23 plus my remainder, which is 48 over x minus 2. Okay, that is my solution. There we go. Okay, now let's check out synthetic division. Okay, let's check out synthetic division. So synthetic division, you're basically doing the same process. However, it's way easier because you're just paying attention to the coefficients. Okay, so let's remember that this is our answer for this one because we're going to end up with the same answer again. Okay, so I've got 4x cubed plus x squared plus 5x plus 2 divided by x minus 2. So here's what I'm going to do. This is how I'm going to set it up. Okay, I'm going to set it up with a little kind of long box like that. I'm going to list out my coefficients. 4, 1, 5, and 2. This last section, that's going to be my remainder down there. Okay. Over here, I'm going to use the opposite of this. I'm going to use 2. Okay. So here's what I'm going to do. Again, this is synthetic division, okay? So I'm going to bring down. The first step is you bring down this first coefficient, okay? And that's 4. And that's kind of hard to read, sorry. Okay. 2 times 4 is 8. 1 plus 8 is 9. Okay, 2 times 9 is 18. Add. 5 plus 18 is 23. Okay. 2 times 23 is 46. I add. My remainder is 48. Okay, now what I do is I take this first term and it's going to be 1 less degree than what I started with. So here I started with a 3rd degree. So this becomes 4x squared plus 9x plus 23 plus my remainder, which is 48, over x minus 2. And it's always like magic to me, right? There we go. This is the same thing, right? You end up with the same answer because it is the same answer, okay? Of all, I literally just did synthetic division. This is synthetic division. Okay. Leading coefficient of this one should be 1. And technically you can still do it, you just have to divide it. And the reason for that is kind of based off of, is it Descartes' rule? But the reason for that is because the reason I flipped this to be 2 is because that's my actual root, right? It would be like x minus 2 equals 0, so I use a positive 2 here. So if it were like 2x minus 3, if I used 3 over 2 here, I could still do synthetic division. But it gets a little bit tricky when that's not a 1. When that's not a 1, it gets a little bit tricky. Okay. All right. So we've got some questions about just a little bit of time left. So we've had some questions about about rationalizing and with radicals. Okay, so let's go over radicals a little bit. I did it at the very beginning when we were talking about imaginary numbers. But when you've got radicals, something like square root of 27, okay, we want to see what are the okay, so when we have something like that, we're going to look at what are the perfect squares that are the factors in there. So 27 is 9 times 3. I can take the square root of 9, but I can't take the square root of 3. So the square root of 9 is 3. And then the square root of 3, it just stays as the square root of 3. Okay, so I know there's a lot of 3's going on right there, but really if you look at it, okay, this 3 here, I kind of highlighted, is this 3 here. Okay, so I can't take the square root of 3, so it has to stay underneath the little radical sign. Okay. Now, if I had something like 3 root 3 and I added 4 root 3 to it, 4 root 3 plus 3 root 3, we just treat these radicals sort of like variables, and this would be 7 root 3. Okay. Now, one thing that we usually have is where we talk about when we're dividing radicals or like simplifying that, rationalizing the denominator. Okay, so when we're looking at that, it's if you have something, for example, like square root of, I don't know, 10 over 3. Okay, the square root of 10 over 3 is the same thing as the square root of 10 over the square root of 3. Okay. 10 over 3 can't be simplified as a fraction. Root 10 can't be simplified as a radical because it's not made of any perfect squares. Root 3, it can't be on the bottom. You can't have a radical on the bottom. Technically you can, but most teachers make you rationalize it because most answer keys in textbooks make you too. It's left over from when you couldn't really do this in a calculator, but now you can. But regardless, rationalizing the denominator. Okay, so what we're going to do is we can always multiply anything by 1. Okay, we multiply anything by 1 and it's going to be itself, right? So I'm going to multiply it by 1, but I also remember that multiplying a radical by a radical kind of cancels out those radicals, right? Like root 3 times root 3 would be 3. Root 9 times root 9 would be 9, right? So I'm going to multiply by a version of 1 that's going to help get rid of that radical. So I'm going to multiply by root 3 over root 3. I'm just multiplying it by 1, so it's still going to be the same thing. So root 3 times root 3 equals 3. A root times a root equals what's underneath it. Root 10 times root 3 becomes root 30. Again, I can't simplify root 30 because it's not made up of any perfect squares. So that's what I've got. So when we are when we are rationalizing the denominator, this is the same thing for I. I can't be on the bottom either. So you would multiply by I over I. Okay, so we want to multiply by a radical, but you've got to multiply it by the radical over itself. Okay, so if I had something like, let's see, so if I had another one, let's say I have 5 over root 5 over root 10. Okay, we'll do that. Okay, so 5 over root 10 can't have the root on the bottom. Okay. So I'm going to multiply by a version of 1 that's going to help me get rid of that root 10. So I'm going to multiply by root 10 over root 10. Root 10 times root 10 gives me root of 100, which is 10. And then I have 5 root 10 on the top, because it's 5 times root 10. When I look at this, I can actually simplify this 5 and this 10. So this becomes, 5 over 10 is 1/2, so this becomes root 10 over 2. And that's it. So what I tell my students, so you don't really have to rationalize the denominator, but the issue is that like on the SAT or in textbook answers and stuff like that, they're not going to write it like this. It's not going to be 5 over root 10. That's not going to be an option. this is going to be the option. So recognizing that this is the same thing as this, that's why we want to learn this part. Okay. It does look a little bit nicer, I guess, but I don't see what's wrong with this. Okay. Let's see. A no solution equation. You have a test tomorrow and it makes no sense. Okay. A no solution equation. Linear equation, I'm assuming. So a no solution linear equation. So when you're solving linear equations, okay, so this is getting back into like algebra 1 type stuff, right? Maybe pre-algebra. Okay. What you're trying to figure out is what value for x or whatever variable, right, makes the statement true. Okay, so let's take a look at this. So I've got 2 times x plus 4 equals 2x minus 1, okay? So go ahead and solve this one. Okay, so yo, Aunt, you gotta be a little more specific. I mean, because some 6th graders are doing stuff like this. So give me a little idea of what you're looking for. All right, I'll write down completing the square if we have time, but I don't know if we're gonna have time tonight. Ooh, I don't know if we're gonna have time to do Kramer's rule, Logan. So we've got this one, okay. All right, so the first thing I'm gonna do is I'm going to distribute that 2. I'm gonna distribute this 2. So now I've got 2x plus 8 equals 2x minus 1. Okay, now again, I want to go ahead and I want to get all my x's on the same side, right? So I'm going to add 1 to both sides, and I've got 2x plus 9 equals 2x. Then I'm going to subtract 2x, and uh-oh, here's the problem. 2x minus 2x is 0. And I have 9 left over on this side. Will this ever be true? Is 9 ever going to equal 0? No. There is no value of x that's going to work to make this true. So this is no solution. Okay, this would be a no solution because 9 doesn't equal 0. Now, the other option that could show up, another kind of weird option with equations, is let's see if we have okay, so let's see if we have something like this. Oh, why add 1 instead of subtract 8? You could subtract 8. That's fine. You could do either one. Okay, yeah, but I just prefer adding 1. I don't know. Just seems easier, but it's the same thing. Sam, I teach mainly 10th and 11th graders, so like algebra 2. All right, so look at this one. So 3x plus 4 is fine. All right, but I need to, over on the other side, I need to distribute this. So that gives me 3x plus 3 plus 1. Okay, so now I've got 3x plus 4 equals, I can combine the 3 and the 1, it equals 3x plus 4. Isn't that always going to be true? Right? I can keep going. If I subtract 4 from both sides, 0, 0. So that means 3x equals 3x. If I subtract 3x from both sides, I get 0 equals 0. Won't that always be true? And even if I did subtract 3x from both sides first, I would have 4 equals 4. That's always going to be true. So this is not no solution. This is infinite solutions, or sometimes you say all real numbers. So this is infinite solutions. Any value for x that I choose is going to solve this. Okay, if x equals 2, 3 times x, that's 6, plus 4, that's 10. 3 times 3 is 9, plus 1, that's 10, so 10 equals 10. If x is 1, that's 3 plus 4, which is 7. 3 times 2, which is 6, plus 1, which is 7. It doesn't matter what I choose, so that's the difference, right? Is that if you end up with something that's always true, like 0 equals 0, 1 equals 1, 2 equals 2, negative 3 equals negative 3, 3x equals 3x, okay? You can say infinite solutions, or sometimes you have this little symbol. It's sort of like this weird uppercase R. It's all real numbers, okay? So infinite solutions is when it's always going to be true, no matter what. No solution is if it's not a true statement. 9 equals 0. That's never going to be true. It's no solution. There's no way to make 9 into 0. No solution. There's a bajillion ways to make 3x equal 3x. It's infinite solution. Okay. Would this be on a GED? Yeah, it could be. It could be on a GED exam or something like that. Okay. So let's see. Okay, so the last thing I'm going to do is the triangle theorem. So the triangle theorems with AAS, with SSS. So what I'm going to do though is I'm going to just kind of show you what they mean. Okay, so you can, let's see, so you can do, so we've got SSS. So these are for triangle congruence or similarity, right? So SSS, SAS, AAS, ASA, and then HL. I know, I think everybody who's in geometry is doing this right now. Okay. Okay, so here we go. So if I have two triangles, let's go with this. Let's do, I have a diagram. I don't know why I drew it like that, but okay. All right, so if I've got this angle and this angle are congruent, and I have this side and this side are congruent, okay? We'll just say those are triangles. Okay, so we've got A, B, C, D. So this angle here is congruent to this angle here. So this is all the information that we're given. Now it's up to us to figure out, like, what do we know based on basic geometry stuff, right? I'm looking at two triangles and I'm trying to see, are they congruent? So I know that this side is congruent to this side, okay? And then I also know that this angle is congruent to this angle. Now I also know that this side, AC, exists in both of these triangles. And I also know that it's congruent. It's going to be congruent to itself, right? So what I have here is I need to go in order. There's an order to these. There's a reason why it's SAS and not ASS, right? There's a reason, and that reason is because that is the order in which you can actually use it to prove that these are congruent, okay? So this is side, angle, side. This would demonstrate SAS. It's two sides and their included angle. So the two sides are what make that angle. Side, angle, side. So in this case, we would have triangle, we could say DAC is congruent to triangle. Now the order matters, right? So DAC is going to be congruent to BCA. Okay. All right, somebody asked in the chat, CPCTC, corresponding parts in congruent triangles are congruent. CPCTC, that's what it is. Corresponding parts in congruent triangles are congruent. So corresponding parts like DA corresponds to BC. They are congruent. They're corresponding. Okay. All right, so then that's SAS. So let's do another one, right? So AAS. Or, well, actually, I'll just give you another figure and let's see if I can figure it out. Okay. F, G, H, I, J. Okay. Let's say, I'm going to give you a little information. I'm going to say G is the midpoint of Fi and JH. Okay, so that's what you're given. Why is there a number on the bottom but not the top in the middle? Here, that's just labeling that point right there, that G. Okay. So if G is the midpoint of Fi and JH, so this is the information that we're given. Now it's up to us to mark this diagram up, okay? So G is the midpoint, which means it cuts it in half, right? It's in the middle. So G is the midpoint of Fi, so that means that this section and this section are congruent. And that also means, it's the midpoint of JH, so that also means that this segment and this segment are congruent. So I've got two sides that I know are congruent. So if I can figure out that the third side is congruent here, I could do SSS. If I can figure out an included angle that's congruent, I could do SAS, right? I can't do ASS because that's something different, okay? But I've got two sides, so I know it's going to be one of these two things. Now, JF and IH, there's no real information for me to figure out that those are congruent. But there's one more piece that's always going to be true. This angle and this angle are congruent because they are vertical angles. Okay? So once we figured that out, we've got side, angle, side. Side, angle, side. So this is going to be proven using the side, angle, side. I think side, angle, side is a postulate. I can't remember if it's a postulate or a theorem, but it would be side, angle, side because we've got the two sides and the included angle. Okay. We're not doing proofs. We're just proving stuff. We're not doing proofs. You still have to prove stuff. You don't have to write a proof for it. Okay, so now if we wanted to do a congruent statement, okay, we would do, so the first triangle in our congruency statement, it doesn't really matter what order we go in. I'm just gonna go JGF, okay? What matters is that then our other half of that, our other triangle, does have to be in the matching order, the CPCTC, right? The corresponding part. So angle J corresponds with angle H. Be careful with these, right? Angle J corresponds with angle H. So J is first, H is first. Angle G here is going to correspond still with angle G in this one, because G is G. So it goes J, G, F. It's going to go H, G, I. And there we have it. Okay. All right, guys. So, sorry we couldn't get to everybody's questions. But, let me see. AJN Shark over on YouTube. I'm going to guess that you're one of my students by that question. Okay. I'll do one more because I think that's one of my kids and they have a test tomorrow. So I'm gonna do one more. So the question is, let me get graphs. Okay. All right, so solving to find an orthocenter, and this is going along with geometry. Okay, solving to find the orthocenter using a system of equations. Okay. All right, so the orthocenter of a triangle is a center of a triangle that's made up from the altitudes of a triangle, okay? So I'm going to go through and I'm just gonna make up this triangle. Okay, let's go here and we'll go here and we'll go here. That shouldn't be a right triangle, okay. All right, so here we've got our triangle. So let me see, this is -6, 1. This is 0, 4. And this is -6, +6. Okay. All right, altitudes. Altitudes are gonna they're 90 degrees, so they're perpendicular to the side from the opposite vertex. Okay, so this side here, the altitude, since this is a vertical line, the altitude is going to be a horizontal line because that's going to be perpendicular, right? That's going to be 90 degrees. Now, where I'm going to draw it from is for this side, I start from this point. So my altitude is going to be like this. That is my altitude for this side right here. It's 90 degrees and it's through that point across there. All right, so now the other one, let's see. I'm gonna do this line here, okay? So here I've got, let's see, between these 2 points, I need to figure out my perpendicular slope, right? So in order to figure out my perpendicular slope, let's go ahead and let's just name these A, B, C. Okay. So my slope for side AC is going to be, let's see, it's down 2 over 6. So it's down 2 over 6. So that's going to be -1/3. Okay. So my slope that's going to be perpendicular to that, so perpendicular to the slope of AC is going to be +3. So since this line here, AC, I've got my perpendicular slope of 3. I'm not going to start it from A or C. I'm going to start it across from B. So I'm going to go from B, I'm going to go up 3 over 1, up 3 over 1. So you can see now that it's not going to be a perfect, nice, clean intersection, right? I'm just going to use this as a straight edge. So this is an altitude, and where they intersect is my orthocenter, but it's not exactly right at a lattice point, right? It's not like 2, 3, right? It's nothing friendly like that, because of course it's not, right? Okay. So I need to figure out what that is. So first, I'm going to use a system of equations to figure out what that is. I just need the equations of my 2 lines. This line right here is really easy to write the equation for. A horizontal line is just going to be y equals 4. Okay. Now what that means is I know that the y coordinate of this orthocenter is 4. I know that because y equals 4, it crosses that line. So by definition, like that's going to be my y coordinate is 4. But the other one, I need to figure out what that line is. Now it's going from -6, 1. And this point here is, let's see, -1, 2, 3, 4, 5, -5, 2. So what I'm doing right now is I'm really just, well, actually, hold on. Because I already know my slope. I don't need another point. I already know my slope for this line here, right? It's 3. That's this line here. The blue line is 3. And it's passing through -6, 1. Now, last year, I know you guys spent a lot of time writing these equations, right? I've got a point and I've got my slope. Point slope form. So point slope form, I have, let's see, y minus 1 equals 3 times x plus 6. Okay. So that's going to be y minus 1 equals 3x plus 18. So my equation for this one is going to be y equals 3x plus 19. Now I can't graph that whole line, right, to go get up to the y-intercept on that. Okay, but now what I'm going to do is I'm going to take, so this right here, this is my blue line. This is my altitude. So I know I've got 2 equations that I need to have intersect, right? My 2 equations for my system are y equals 4 and y equals 3x plus 19. These are the equations of my 2 altitudes. And I'm trying to figure out where they intersect. Now I know that they intersect and my y value is 4. So all I need to do with this one is I just need to plug in 4 for y. Okay, so my y is 4. So I've got 4 equals 3x plus 19 because I know that 4 is going to be that 4 there. Okay, so minus 19. Yeah, I did this all right? X plus 6, y minus 1. Yep. Okay. So then this is -15 equals, maybe I did do that exactly right. 3x divided by 3 divided by 3, which is -5 equals x. Okay, so my coordinates are -5 and positive 4. This was probably just the way that I drew this with the thick markers that it wasn't exactly at the points. But when I look back here, right, when I look at my graph, all the way back here, -5 and 4. Okay, it's a little bit off, but that's okay. Okay. So that's where we're going to get this. You've got the different equations. Okay. You've got the different equations, and then you're going to solve them to figure it out. Okay. That's all I got. Okay. So have a great night. We've been way over the time, but that's okay. All right, guys, I will see you all next week. Thank you for joining us, and have a good night.